Alright, today we're going to look at a minimal path problem, or a path that would minimize time, and it's going to be kind of similar to the one we started in class today. What we're going to do is we're going to have a runner who is on one side of a river, and he wants to get to a spot on the other side of the river, and the river is 50 feet across, and if he starts right here, the spot he wants to get to is 200 feet downriver. And he knows that he can run at 3 feet per second. Yeah, let's go meters. Let's call this meters. Make it a little more realistic. 3 meters per second. And he can swim at 2 meters per second. So what we want to know is how far should he run before swimming? Okay. So what I'm going to do is I'm going to break this into a triangle. We know this is 50, and I'm going to call this x. I'm going to call this 200 minus x. The distance he runs is 200 minus x. So that makes the distance he swims x squared plus 50 squared, but the square root of that. Okay. Now, if we think about the time he spends, that equals distance divided by rate. Well, basically what we can do is think about this thing in terms of two different times. We can think of this as the time that he runs and the time that he swims, and the total time is going to be the sum of those two times. So to set up a time equation, we're going to get t equals the distance he runs, okay, divided by how fast he runs, his rate, but I'm going to multiply that by 1 over 3. Right, that's the same as dividing by 3. And to that I'm going to add the distance he swims, and I'm going to multiply that by 1 over 2, or divide by 2 the rate at which he swims. Okay, so there we have an equation for time. And what I'm going to do is I'm going to simplify that just a little bit. We've got t equals, when we started with 200 minus x times 1/3 plus x squared plus 50 squared to the 1/2 times 1/2. Okay. I'm going to simplify this. I'm going to call this 200 over 3 minus x over 3. And I'm going to bring the 1/2 out here. X squared plus, I'm going to call that 2500. 50 squared is 2500 to the 1/2 power. Okay. So now what we want to do is minimize the time it takes him to get from where he is to where he wants to be. Okay. Now, what could we do? Well, we could take the derivative of time and set it equal to 0, and that would give us the minimum value. So what we really want is dt dx, or we could even call this thing t prime if we wanted. Derivative of 200 over 3 is 0. The derivative of negative x over 3 is negative 1/3 plus. Now the derivative of this thing, 1/2 times 1/2 is 1/4 times, we leave the inside alone, x squared plus 2500. 1/2 minus 1 is negative 1/2, and the derivative of the inside is 2x. Okay. And what we want to do is take and set that thing equal to 0. I'm going to combine some terms here. I'm going to have negative 1/3 plus, this is going to become x over 2 times x squared plus 2500 to the negative 1/2 power, and that's going to equal 0. Okay. Well, now what I'd really kind of like to do here is start solving for x, so I can move the negative 1/3 to the other side, where I will have 1/3 equals x over 2 times, and this is x squared plus 2500 to the negative 1/2 power. Well, if I multiply each side by 2 and multiply each side by x squared plus 2500 to the positive 1/2 power, I get 2 times x squared plus 2500 to the 1/2 power over 3 equals x. Okay. So now if I multiply each side by 3/2, I get x squared plus 2500 to the 1/2 equals 3x over 2. Well, now what I can do is square each side. Alright, and that's going to give me x squared plus 2500 equals 9x squared over 4. And now, if I subtract x squared from each side, I get 2500 equals 5x squared over 4. And now I can solve for x squared, and that gives me x equaling 44.721. So now, if we think back to our picture, well, it looked something like this. Right? It was 200 meters down the other side of the beach. This was x. Okay. So we would have this point, or this distance, equals 200 minus 44.721. And if I can do that quickly before my next class rushes in, and so he should run for 155.279, and that's meters. We don't know what he's trying to get over here. Perhaps it is some guy in there, is one of Carly's friends over here, who of course has it going on, that he is trying to get to. So, there you go. We'll talk about this on Monday some more, and I hope your weekend is nice.